Hello,
Good evening, sir.
good evening.
Good evening, sir.
Good evening. So, do you have any doubt from first term syllabus, calculus, or something else?
No.
No, sir.
So, let's start with the second term syllabus with mechanical properties of solids. Mechanical property of solids. To define this, let me define you some term. Suppose there is a support and a string is connected with it, having length L. So if you apply a deforming force on it to compress it or to elongate it, so it may acquire this shape and this shape according to the application of deforming force. So if you apply a deforming force along this direction, so it may acquire this configuration, or if you apply deforming force along this direction. Now this spring has the ability to develop or induce a force opposite to this deforming force, which is called a restoring force, due to which it will tend to regain back to its original state or original shape if you remove this deforming force over it. So this tendency of a spring by which a force get induced into it, which will tend to bring this spring back to its original state, is called elasticity. Is it clear?
Yes, sir.
So first we define in this part, what do you mean by elasticity? Let's say for this part, if you apply a deforming force on a particular spring, there will be change in shape on it. So it may acquire this configuration while compression, or it may acquire this configuration while stretching. So in these two terms, or in these two states and this particular spring, there will be some restoring force opposite to its deformation, which tend to bring this spring back to its original state. This is called elasticity. Similarly, in a solid, suppose arrangement of particle is on the vertex of a cube. And each vertex is occupied by particle of that particular solid, atom or molecule, like this. Now we consider the bond in between them behaves as spring-like structure. So it may have acquired so on it, if you apply a deforming force along any direction to deform its shape, let's say along this direction. So this body will have a tendency to develop a restoring force on it, which will tend to bring this point back to its original state. So this tendency of solid or object is called elasticity. Prachi, is it clear?
Yes, sir.
So we can define elasticity as the tendency of a body to regain its original shape on removal of deforming force is called elasticity. There is another property which is opposite to it, which is called plasticity. So it will be the inability of a solid or a particular object due to which it can't regain its original shape on removing force. This inability of a body is called plasticity. So we can define plasticity as the inability of a body so that it can't regain its original shape on removal of deforming force is called plasticity. Karthik, any doubt?
No, sir, it's all clear. Sir, I
Good.
had to ask one thing.
Yes.
That the deformation caused by, in the case of elasticity, is known as elastic deformation, right?
Yes.
Okay, sir.
So for elasticity, we may define some substance which having elastic behavior. So in general, there is no any object which is perfectly elastic behaving, but there would be some substance which tends to be. So first, for elastic or most elastic substances, quartz. Similarly, plasticity, there will be no any substance which is perfectly plastic. There will be property in between elasticity and plasticity. But in general, we can say wax having most plastic behavior. In general, property of a body lies in between elastic and plastic. So we can say behavior of a body lies in between elastic and plastic. Prachi, any doubt till this part?
No, sir.
Okay, just write it down till this part.
Finished, sir.
Prachi, you have written?
Yes, sir.
Okay. Now, on the basis of this deformation, elastic behavior, we may define some term. First is stress. Suppose there is solid attached to a rigid support. So if you apply deforming force on it along this direction, over this cross-sectional area, so we can define first stress. The amount of deforming force applied on a body per unit cross-sectional area is called stress. Next, due to this deforming force, there will be some change in its shape. Let's say this rod may get elongate to this point. So original shape of this particular rod is from this point to this point, and there is some deformation in it from this point to this point. So we can define or we can calculate this deformation by a quantity or physical quantity that is called strain. So strain basically defines you the amount of deformation produced in this body or a body on application of stress on it. So first, stress is the amount of deforming force applied on a body per unit area of cross section is called stress. We can write stress equals to deforming force divided by area of cross section. Now, unit of force is Newton and unit of area is meter square. So we can write SI unit of stress is Newton per meter square. Karthik, is it clear?
Yes, sir, it's clear.
Similarly, if you have to calculate amount of deformation produced in it, so we can define another physical quantity that is called strain. So strain simply defines you the amount of deformation in a wire or a body per unit its original shape. So it is nothing but ratio. The ratio of deformed shape to the original shape. So strain equals to deformed shape divided by original shape. As in this part, we have deformation as delta L and original shape of this body is L. Both measured in terms of length, that is in meter. So if you take the ratio of these two terms, so it will be unitless quantity. So you can say strain is unitless quantity. Raji, is it clear?
Yes, sir.
Okay, just write it down till this part.
Finish, sir.
Finished, sir.
Okay. Now we have stress and we have corresponding strain. These two are related with each other, which is defined by another term, which is called Hooke's law. There is some limitation for this term. First is temperature of the system should be constant. Why it would be, I will define you later. Next, stress and strain should be within elastic limit of that particular material. I will define you later what do you mean by elastic limit. So Hooke's law states at constant temperature and within elastic limit, the more you apply stress to a particular object, there will be more amount of deformation produced in it. It means stress and strain should be directly proportional to each other. Is it clear?
Yes, sir.
So we can say
Yes, sir.
at constant temperature and within elastic limit, the strain produced in a body is directly proportional to the stress applied. So you can say stress applied is directly proportional to strain produced. If you replace this proportionality sign by any constant term, so we can write stress equals to some E times strain, where this E is called modulus of elasticity. Now, this modulus of elasticity will define you first the elastic behavior of substance. So in first part, I have taken temperature of the substance should be constant. Why? If you change the temperature of a substance, it means on increasing temperature of material, bond between particle get weakened. Then separation with the particle will increase. So it will lose their ability of elasticity or elastic behavior. So this modulus of elasticity E would depend or vary with change in temperature. So Hooke's law may not valid in that case. That's why we take temperature should be constant. Is it clear?
Yes, sir.
Yes, sir.
So first is modulus of elasticity and its depending factor. It defines the elastic behavior of substance. Next, it depends upon two factors. First is nature of material and next is temperature. So it depends upon nature of material and temperature. So modulus of elasticity inversely proportional to temperature. Next, this modulus of elasticity will be constant at a particular temperature for a particular substance. So it will be independent of change in dimension of the body. It means it will be independent of the radius, area, length of that particular object. So it is independent of dimension of body, length, radius, diameter, area, and so on. Prachi, is it clear?
Yes, sir.
Now we can define a graph related to this relation. Since stress is directly proportional to strain, so for directly proportional, graph will be straight line like this. This is amount of stress applied, and this is corresponding change or deformation strength. So if you rearrange this equation, you will get E equals to stress divided by strain. So according to this graph, this is nothing but ratio of perpendicular and base. So as we know, ratio of perpendicular and base will be tan theta, and which will define the slope of that particular curve. Let's say inclination is theta. So E must be equals to tan theta. So we can write slope of stress strain curve will define modulus of elasticity. Next, we can say, since strain is a unitless quantity, so unit of stress is Newton per meter square. So modulus of velocity will have unit equivalent to stress. So SI unit is Newton per meter squared. Karthik, any doubt till this part?
No, sir.
Okay, just write it down till this part.
No, sir.
Finished, sir.
Okay. So do you have any doubt till this part? Karthik, Prachi?
No, sir.
Okay.
Sir, if they ask like for that constant temperature, if they ask any example, like the example of steel, like if we heat it more, it will become more elastic, right?
No, no, just I have defined you in this part. Elasticity or modulus of elasticity will be inversely proportional to temperature. It means if you increase or raise the temperature of a substance, particles of that particular material may get separated from each other or bond get weakened, due to which elastic behavior of substance decreases. Is it clear?
Yes, sir.
Now, we have these three terms, stress, strain, and Hooke's law. So on the basis of these three terms, we may define its type related to a different body. Before that, let me ask you a question. We have two different material whose stress versus strain curve is given A and B. Suppose inclination from this point to this point is 30 degree and inclination from this point to this point is 60 degree. So you'll be asked to calculate, find ratio of modulus of elasticity of A and B. I had just defined you in the previous part how to calculate modulus of elasticity related to a stress strain curve. Just use that concept and try to find. Prachi, any problem?
No, sir.
Okay. Just solve this and send your answer in chat box to me. Prachi, just check your calculation. Karthik, any problem while solving? Just see.
I'm solving.
Good, Prachi.
Thank you, sir.
Suppose if you have to calculate modulus of elasticity, which is stress strain curve or slope of a stress strain curve, so we can write E is equals to tan theta. So for A, it will be tan 60°. It will be equal to root 3. And for B, it will be equals to tan 30°, which is equals to 1 by root 3. Just divide these two terms. This root 3 will move to numerator. So you will get EA divided by EB equals to root 3 into root 3. It will be 3 divided by 1. So the ratio will be 3:1. Karthik, you got this answer?
Yes.
Okay. So the next thing is types of stress strain or Hooke's law. First is longitudinal. Suppose you have a body which is attached vertically to any support. Now, if you apply deforming force along this direction to stretch it, or if you apply deforming force along this direction to compress it. So in this part, elongation will be along this direction, but in this part, elongation will be along this direction. So this is deforming force, amount of elongation along this direction, delta L, original length of wire from this point to this point is L, and area of cross section is A. So this is called tensile stress. Similarly, if you apply deforming force along this direction to compress it from this point to this point, original length of wire is L and area of cross section is A. So this is called compressile stress. So we first define about tensile. If deforming force is applied on body to elongate it, per unit area is called tensile stress. The deforming force applied to elongate it per unit area. Similarly, compressile stress is to compress it. So it will be the deforming force applied to compress it per unit area. In both these terms, there is only change in direction and nothing more. So we longitudinal stress. Equals to deforming force divided by area of cross section. Corresponding change in its length is defined by longitudinal strain. So it will be equals to delta L divided by L. Now, according to Hooke's law, if you divide these two terms, you will get modulus of velocity. So in this term, it is called Young's modulus. So Young's modulus equals to longitudinal stress divided by longitudinal strain. Young's modulus is denoted by Y, which is equals to longitudinal stress F divided by A, longitudinal strain delta L divided by L. So if you rearrange this equation, you will get F times L divided by A times delta L. And since this Young's modulus is basically types of modulus of velocity, so it will have all the property what we have defined for modulus of velocity. Next, since we are dealing in terms of length only in this part, so this Young's modulus is also termed as elasticity in length. Karthik, is it clear or do you have any doubt?
Confirm, sir. Yes, sir.
Good. Prachi, is it clear?
Yeah.
Good. Just write it down. Prachi, you have done?
Yes.
Okay. Now let me define you a problem related to this. Suppose a wire having length 2 meter, area 4 mm square is hanged vertically. A force of 40 kilonewton is applied to elongate it. Find first longitudinal stress, second corresponding longitudinal strain. If Young's modulus is 2 into 10 to the power 11 Newton per meter square, also find elongation produced. Just use the previous formula and try to calculate these terms. First, let me define you how to approach a problem. First, check the quantity which is given in the question. We have length of wire as 2 meter. Next is area of cross section in 4 mm square, force 40 kilonewton, and Young's modulus 2 into 10 to the power 11 Newton per meter square. Now, next check, are these all quantity is in same SI unit or they are in some different unit?
They're in different units. The area of cross section is in millimeter square.
Good. So how to
Yes, sir.
convert millimeter in terms of meter? Suppose you have 10 to the power 0, that is called base
4
unit.
divided by 10,000. 4 divided by 10 raised to 4.
No. Let's say 10 to the power 0, it will be meter. So 10 to the power minus 1, it will be decimeter. 10 to the power minus 2, it will be centimeter. And 10 to the power minus 3, it will be millimeter. So
4
these
to the
are in
power 10
terms of,
into minus.
yes, Karthik, minus,
The area will be 4 into 10 to the power minus 3.
no. mm is in minus 3, but here we have square. So on squaring it, it will be 10 to the power 0, 10 to the power minus 2, that will be minus 4, and it will become 10 to the power minus 6. So this is in terms of length, and this is in terms of area. So if you have to calculate square in terms of meter square, so just multiply it by 10 to the power minus 6. So it will be 4 into 10 to the power minus 6 meter square. Is it clear?
Yes, sir.
Yes.
Similarly, on going to the higher value, 10 to the power plus 1 will be deca, 10 to the power plus 2 will be hecto, and 10 to the power plus 3 will be kilo. So we have in force 40 kilonewton. So kilonewton is not the SI unit of force. Newton is its SI unit. So we have 10 to the power 3. So just multiply it by 10 to the power 3 to convert into Newton. Prachi, is it clear?
Yes, sir.
Okay. Now apply the formula and then put all the values and simplify it. You have to calculate longitudinal stress. You can't find elongation produced first without knowing these terms. Okay, Prachi? Karthik, you have solved the first part.
Yes, sir. I'm sending on the answer.
Okay. Parachi, you have solved?
Yes, sir.
Just send me your answer.
Sir, I solved it, but while checking, I'm getting some wrong answer.
Okay.
I don't think it's correct.
Suppose for the first part, if you want to calculate longitudinal stress, so stress will be equals to, just 1 minute. Force divided by area of cross section. We have force 40 into 10 to the power 3. Section is 4 into 10 to the power minus 6. So this 4 will cancel out this term in 10 times. This 10 to the power minus 6 on moving to numerator, it will become positive 6. So you will get 10 to the power plus 1, 10 to the power plus 3, and 10 to the power 6. On combining, it will be 10 to the power 10 Newton per meter square. Karthik, is it clear?
Yes, sir.
Since if you have denominator term, so on moving to numerator, its exponential will change its polarity. Since we have minus 6, so on moving to numerator, it will become plus 6. Okay.
Yes, sir.
In next part, to calculate longitudinal strain, we had formula Young's modulus equals to stress divided by strain. So rearrange it to get the strain. So strain will be equals to stress divided by Young's modulus. We have another formula to calculate strain, which is equals to delta L by L. But in this question, we don't have delta L, so we can't use this formula first. So we can calculate a strain by using this relation and put it in this equation to get delta L. So stress is 10 to the power 10, Y is 2 into 10 to the power 11. So it will be 0.5 into 10 to the power minus 1. Karthik, is it clear?
Yes, sir.
Similarly, in last part, if you put the value of strain and L, you will get delta L equals to L times the strain. We have length as 2 meter. Strain is 0.5 into 10 to the power minus 1. So it will be 1 into 10 to the power minus 1, or it will be just 0.1 meter. Prachi, is it clear?
Yes, sir. So I got the stress, but strain, my answer is wrong.
Okay.
And the elongation reduced also, it is wrong.
Okay, no problem. So it is clear now? Okay, just write it down.